All right. So this is a composition of functions problem. We're supposed to find f composed with g of x and g composed with f of x. And I've been given f of x and g of x. And then we're supposed to find the domain of the resulting functions, but I didn't write that down because that's just kind of understood that we need to know those domains. And in this case, those domains are going to be particularly straightforward. Now, what do I mean by composition of functions? I gave this example in class, but what we really have, where we earlier had the algebra functions, where we started adding, subtracting, multiplying, dividing functions by each other, this is more of what I'll call a cascade of functions. It's where one function feeds into another function. The best visual picture I can come up with is something like a waterfall, where when I kind of think of Yosemite Falls from the side, you know, I have these two different levels, and then ground level of the valley underneath, and so I kind of have the mountaintop up here, and then I have this mid-level area, and then the ground level of the valley below, and the water as it falls over the first level, then it falls over the second level, and then it comes down to the ground level. And so when I think about that when it comes to these composite functions, is that we kind of have an input here. I'll try to be consistent with my colors here. I have an input to my f of x function here, and then the output to my f of x function becomes the input to my g of x, be consistent, lowercase g of x function, which then has kind of a joint output or a composed output of the two functions. And so what we're really saying is that our function value passes through one function, then it passes through the other function, then we get an output. So instead of this waterfall drawing, let's draw this more like a flow chart, because that's going to be a little bit more official. And if I draw this like a flow chart, what am I going to have? I'm going to have the box for my f of x function. I'm going to have a box for my g of x function. And then I'm going to have values. I'm going to have input values. And those are my x values. And then between my, not an eraser, a drawing, between my output of my f of x and my input of my g of x, this is the output of my f of x, but it's also the input to my g of x. And then my g of x has kind of this joint output that is the output of that, the composition of these two functions. That's why I call it a cascade, because it reminds me of a waterfall where one cascades into the other. The output of one becomes the input of the other. And so we have our notation here where this actually is going to be G circle F. What I've drawn here is going to be G circle F of X. And I kind of actually hate this notation because it reads left to right. It is clear. It is standard. We need to know it. It is part of the language and the grammar of math. But it is a little bit less informative when you read it, when you're learning. Once you know what you're talking about, it's a great notation. But while you're learning, it's a little bit less informative, a little bit harder to read than something like G of F of X. Because what this tells me to do is evaluate F at the value X, then take the output of that value and run it into G of X. And so in a very compact notation, this statement says that whole flow chart. It says take X, put it into F of X, take the result F of X and put it into G of X, and then you get a result, an output. Okay, now let's actually try to do that with functions, with actual functions, actual numbers. Well, probably not numbers, but functions here. All right, so I've got my f of x equals this x squared plus 3, and I'm just going to do the whole teacher with a tablet thing. I'm going to pull that down, and I'm going to pull this down. Oops, let's not do that. Pull that down and then move the whole thing back up, because that way we have kind of the instruction up top and we can go back to kind of a clean slate here and take a look at the problem. All right. It says F circle G, which I always think looks like fog, but no, it's F circle G of X. And what does that mean? F circle G of X translates directly to, and I read this thing left to right, and it's going to become F of G of X. Well, that tells me that my G of X is the same as this G of X. But wait, that equal sign tells me that this is exactly the same as that. And so what I can do is I can rewrite this as F of, but instead of G of X, I'm going to put that in for my input. And so I'm going to have 4x minus 3 for the input of f of x. Because what I'm doing is I'm saying if x is put into g of x, then 4x minus 3 is the output of g of x. The output of g of x becomes the input to f of x, just like in our drawings up here, except this I said was g circle f of x, and we're doing f circle g of x. And so it's exactly the opposite as far as the functions go. Okay, well, from there, I now want to take this 4x minus 3, that's my input to my f of x, and I want to plug it in for x. Well, that means it just goes in place of my x there. And so that becomes, let's see if we can preserve a little order here by keeping the text color right. So if I do 4x minus 3, and then that's in place of my x, so then that's squared minus 3, because that's x squared minus 3, but because x has been put through the function g of x, x is no longer x is 4x minus 3. Now, to simplify that, because, this is math, and in math we always simplify things, what do I have to do? I have to expand this so that I can combine like terms. Otherwise, I don't have a simplest form expression. Well, this is expanding a binomial, and remember, that's not as straightforward as just squaring the first term, squaring the second term. There's a lot more to that, because that square tells me that I have two copies of the base multiplied together. Multiple ways we can do this. The way I like best is saying this is a minus b squared. Well, I know that a minus b squared is a squared minus 2ab plus b squared. If that works out, then my a is 4x, my b is 3. And so what do I have when I finish writing this down? I'm going to have, we'll do the purple here first, because this is well, it's no longer purple because it's been squared. Okay, so what do I have? I have 16x squared, because that's my 4x squared. And then that's going to be minus 2 times 4 times x times 3, right? Because 4x is my a, b is my 3, so that's 2ab, that's 2ab, and it's minus 2ab, so I have minus 2ab. Okay. So with all that done, now I need to tack on my b squared in the end, and so that's going to be plus 3 squared. So let's just put plus 9 there. Let's not forget that this is not just 4x minus 3 squared, but it's 4x minus 3 quantity squared minus 3. And so we've got to keep that minus 3 from up here. We can't forget that and leave that off, not copy that. Okay, well, now let's just simplify these things a little bit more. So I have my 16x squared. There's a lot that needs to be taken care of here, right? Because I have 2 times 4 times 3 all within the same term here. It will be minus still, right? Because there's just one negative. And so what do I have? I've got 2 times 4 is 8. 8 times 3 is going to be, what, 24? And so I have 24x, and then plus 9 minus 3. Well, that'll be minus, well, not minus, that'll be a plus 6. All right, well, I sort of don't want to, but even though we're kind of done with the educational value of this problem for the example I want to use this for, this is a math problem, and in math problems we go for simplest form answers. And that means I need to try to factor this thing. I need to see what the factored form of this could be. Now, if I look at this, I kind of obviously have a 2 times 3 here. I already had, my 2 and my 3 here, so I can see those two. And my 16, it's 4 squared, so it's all 2s. It's 2 to the 4th. And so I can't pull a 3 out, but I can pull a 2 out front. And so what am I going to end up with? I'm going to end up with 2 times, and I have 8x squared minus 12x plus 3. All right, now, I'm a big fan of this AC factoring method. So we start out by remembering that we label our quadratic ax squared plus bx plus c. And the AC method says multiply a times c together and then look for factors of a times c that add up to b. Then you break the middle term up into those 2 factors, then you factor by grouping. And if I haven't done a video on that, I'll do one here in just a minute, just so that we have some review and reminder of how to do that. Because when I do this one, when I do my a times c here, what am I going to get? I'm going to get 8 times 3, which will give me 24. And when I'm thinking about 24, I'm looking for factors of 24 that add up to negative 12, or have a difference in negative 12. And if I think of 24, well, 2 and 12, 4 and 3, 2 and 2. And so I have 3 2s and a 3. And so that's going to be 2 times 2 times 2 times 2 times 3. And so I'm trying to figure out ways to associate those factors that would give me a difference of negative 12. And so what would that be? Well, they'd have to both be negative for them to add up to negative 12 because it's a positive number. And so, well, what could that be? That could be 1 times 24, but that would add up to, what, negative 25. Negative 1 times negative 24. Okay, well, I could have negative 2 times the rest of that, which would be 12, right? So negative 12, but that's going to add up to, what, the positive 14, if I add those 2 together. And so I could go to negative 3 times, what, 6? So times negative 6, but that's going to add up to negative 9. And so I think I've crossed through, what are my possibilities? Because I'm looking for negative 12, and I've gone from negative 25 to negative 14 to negative 9. If it was going to work, it would have been between those 2. And so I'm going to say this does not factor. And so because it does not factor, I'm going to go ahead and erase the rest of that and say that this is the factored form of my trinomial here. Now, as far as that function goes, of x, what is the domain of that function? We're talking about values of x that work, right? Values of x that yield values of y, that are mapped to output values, input values that are mapped to output values. And because this is a polynomial, well, there's really 2 ways we've talked about excluding values from our domain. One is if we're dividing by 0, if a value of x causes us to divide by 0. The other is if a value of x causes us to have a negative number underneath an even radical, like a square root or a 4th root or a 10th root or a 212th root. But any even radical or fractional exponent 1 over 2, 1 over 4, that an x value causes to be negative, that's out of our domain as well. Well, in this case, I don't have any fractional exponents, I don't have any radicals, and I don't have any rational functions. I don't have any division by x. And so, since this is a polynomial, all polynomials have a domain of negative infinity to infinity because they don't have any of those things. They don't have any of those possibilities. And so in this case, it's really easy. This is a polynomial which implies that our domain is negative infinity to infinity. And we could also say that our x is an element of all real numbers. We could say that is our set notation version of this. All right. That was the first half. Now, for the example's sake, let's try it in the other direction just to make sure that we have an idea what we're doing here. So if that was going left to right, well, F circle G. Now let's try finding G circle F. So I want to create a dividing line. We're doing something new here. Let's go back to that, paste my writing in here, and erase some of my rather extravagant marks there. All right. And so now we've already found F circle G. So what am I trying to do? I'm trying to find G circle F because I already found F circle G. So find that. Well, F circle G was f of x. And so G circle F, that's going to be, again, read from left to right here. That's going to be G of f of x. And that's going to be the same thing as G circle F. It's a circle, not a times. This is not algebra of functions. This is composition of functions. And so if that's G circle F, that is not golf or golf for you Detroit fans out there. This is G circle F of x. And so that gives me my G of f of x. Well, what do I need to do? I need to take this, oops, it changed me to an eraser. I'll write it down here, why not? So G of f of x. This is my input. It's my input to x. F of x is the same thing as f of x. But that is the same thing, because of this equal sign, that is the same thing as x squared minus 3. And so I can rewrite this as G of, and then put that in for the input. Put the x squared minus 3 in for the input of my G of x. All right, well now I want to take that x squared minus 3 and I want to plug it in for the input of x in my G of x. Well, that's the same thing as putting it in for x on the right-hand side of the equation. Well, what's that going to give me? That's going to give me that instead of G of x, or G of x squared minus 3, I'm going to write this as 4 times, and then instead of x, I'm going to put in x squared minus 3, and then minus 3, because this is the same function as this. It's just instead of putting an x in, I'm putting in the output of my f of x function. Okay, well, now how do we simplify that? I just have to distribute that 4 through. And so I have 4x squared minus 12 minus 3. I have 4x squared minus 15. This is also a polynomial, which implies my domain is negative infinity to infinity. And remember, we use parentheses because infinity is a concept, not a number, so you can never reach infinity. And this is not some sort of weird mushroom on its side. What this is actually supposed to look like is an equal sign, and then an arrow, like a greater than sign next to the equal sign, but I'm doing a terrible job writing it. But this is kind of what it's supposed to look like, is an equal sign, but with an arrowhead on the right-hand side. That just means the thing on the left implies the thing on the right. Okay. real quick reminder, just because I've been using the word polynomial for a bit. A polynomial is anything that fits the form, anything that fits the pattern, p of x. So polynomial. This is a big, ugly definition, but it's a useful one to remind ourselves of. So it's going to be a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus this dot, dot, dot means follows that pattern. A sub 2, x squared, a sub 1, x to the 1, a sub 0, and you can kind of think x to the 0, but x to the 0 is 1, and 1 times a sub 0 is a sub 0, and so we don't write any of that. And so what I'm really then saying is that my a sub n's are real, that's an R, R-E-A-L, real valued constants. And my n's are positive integers. That would be like 1, 2, 3, dot, 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 up to infinity. Well, when I say 4x squared minus 15 is a polynomial, what I'm really saying, so if I want to match p of x to 4x squared minus 15. What am I saying here? I'm saying I have 4x squared plus 0 times x plus negative 15 plus 0 times x cubed plus, and all of those above it would be 0. And so what I'm really saying is that my a sub 3 and greater are 0. My a sub 1 is 0. My a sub 0 equals negative 15 because this is my plus a sub 0, right? And so I have my 4x squared. Well, that means that my a sub 2 equals 4. And then the x squared is, it follows that same x to the n pattern. And so what I'm really doing is I have my 4x squared, that's really thinking of, well, okay, I'm not explaining this well. Let me write this slightly differently. If I've got that 4x squared there, that's my a0. That's my a1, x to the 1. That's my a2, x to the 2. That's my a3, x cubed, plus dot, 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 larger. Well, since this term doesn't exist in this, the a3 is 0. Since this term does exist, then I have to match up and find out what the constant is. And I don't expect you to do this. I don't expect you to write this out. I just want you to recognize that this is why, that the fact that this thing will match up with that form is why this is a polynomial. Terms separated by addition. X raised to positive integer powers separated by addition. That's an informal way of thinking about what is or isn't a polynomial. All right, I hope that helps us work these problems.